Good day. Today, I will be discussing about the film processing. Introduction. Film processing procedures have a direct effect on the quality of a radiograph. Latent image formation. When the radiation interacts with the silver halide crystals in the film emulsion, the image on the film is produced. The image which is not visible before processing, it is called the latent image. Figure 1. This image is where scanning electron micrograph of unprocessed emulsion of Kodak ultra-speed dental film. It has a 500 times magnification. So note that there white appearing unexposed silver bromide grains. Dental X-ray film processing. Processing is a series of steps that changes the latent image on the exposed film into a radiograph by producing a visible image on the film. Proper processing is just as important as exposure technique in producing diagnostic quality radiographs. Radiographs that are non-diagnostic because of poor processing techniques must be retaken, exposing the patient to unnecessary radiation. In many practices, intraoral films are processed in an automatic processor. However, it is still necessary to know how to process the film manually. So there are 5 steps in processing dental radiographs. First, development. Second, rinsing. Third, fixation. Fourth, washing. And last but not the least, drying. First, developing. So developing is the first step in processing films. A chemical solution called the developer is used. The purpose of the developer is to chemically reduce the exposed silver halide crystals to black metallic silver. The developer solution also softens the film emulsion during this process. Rinsing. So rinsing of the films is necessary to remove the developer from the film so that the development process stops. Usually, agitating the film rack for 20 seconds is sufficient. This must be done under safe light conditions. Next one is the fixing. So the acidic fixing solution removes the unexposed silver halide crystals from the film emulsion. The fixer also hardens the film emulsion during this process. For permanent fixation, the film is kept in the fixer for a minimum of 10 minutes. However, films may be removed from the fixing solution after 3 minutes for viewing. Films that are not properly fixed will fade and turn brown in a short time. Leaving films in the fixer for a long time can remove the image from the film. Next is the washing. After fixation, a water bath is used to wash the film. The washing step requires about 20 minutes to thoroughly remove all excess chemicals from the emulsion. Drying. It is the final step in the film processing, is the drying of the films. Films may be air dried at room temperature in a dust-free area or placed in a heated drying cabinet. Films must be completely dried before they can be handled for mounting and viewing. Film processing solutions. So the film processing solutions, they are available in the following forms. First, the powder. Second, ready-to-use liquid. And the third is liquid concentrate. Processing a unit chemistry. Developer 20 to 25 seconds. Reducing agent. So electron donor continuous latent image formation process. Phenidone rapidly produces fine detail shades of gray. Hydroquinone slowly produces heavy densities. Activator. It is sodium carbonate produces alkaline pH or other chemicals to function as well as gelatin. Restrainer. It is the potassium bromide which decreases reducing agent activity, prevents chemical fog. Preservative, which is sodium sulfate, controls oxidation buffering agent. Next one is the hardener, which is glutaraldehyde. It controls gelatin swelling to minimize risk of physical damage. Next is the solvent. It is where water dissolves chemicals and dilutes them to proper concentration. Fixer to 20 seconds. So they are clearing agent, which is ammonium thiosulfate. It removes and develops silver halides from emulsion. Next is the activator, as it is acetic acid, provides acidic pH for other chemicals to function, stops reduction. Next is the hardener. Potassium alum hardens emulsion to minimize risk of physical damage. Next is the preservative. Sodium sulfate maintains pH. Solvent. Water dissolves chemicals and dilutes to proper concentration. So here in figure 2, the concentrated solutions of film developer and fixer. So the dark room. It is the term light tight. It is often used to describe the dark room. To be light tight, no light leaks can be present. When you are in the dark room with the light turned off, no white light should be visible. So the X-ray film is extremely sensitive to visible white light. Any leakage of white light can cause film fog. So a fog film appears dull gray, lacks contrast, and non-diagnostic. Types of darkroom lighting. So first, the room lighting. It is an overhead white light provides adequate lighting for tasks such as cleaning, restocking of materials, and mixing of chemicals. Safe lighting. A safe light is a low-intensity light in the red-orange spectrum. Safe lighting provides enough illumination in the darkroom to process films safely without exposure of or damage to the film. Types of darkroom lighting. So there must be a safe distance between the light and the working area, and the person developing the film must work quickly to keep the exposure to the safe light as short as possible. Unwrapped film that are left too close to the safe light or exposed to the safe light for more than 2 to 3 minutes appear fog. A safe light must be placed a minimum of 4 feet away from the film on the working area. So here in figure 3, it shows a distance of at least 4 feet must separate the safe light from the working area. So the processing tanks. So manual processing is a method that is used to develop, rinse, fix, and wash dental X-ray films. The essential piece of equipment required for manual processing is a processing tank. The processing tank is divided into compartments to hold the developer solution, water bath, and fixer solution. A processing tank has 2 insert tanks and 1 master tank. So here in figure 4, show reprocessing tanks showing developing and fixing tanks inserts in bath of running water. Next is the requirements for a dark room. Cleaning needs at all times, infection control items like gloves, disinfectant spray, paper towels. Container labeled with a biohazard label for contaminated film, packets, or barriers. Recycle container for pieces of leads, foil pieces which should not be thrown in the trash. Light tightness, processing tanks for the developer and fixer solution, and a circulating water bath. Running water with mixing valves to adjust the temperature, both a safe light and a source of white produce normal light. So accurate timer, accurate faulting thermometer, stirring rods or paddles to mix the chemicals and equalize the temperatures of the solutions, safe storage space for chemicals, film hangers, film drying rack, and film dryer. The automatic processor. So automatic film processing is a fast and simple method used to process dental X-ray films. Other than opening the film packet, all steps of film processing are handled by the automatic processor. Automatic film processing requires only 4 to 6 minutes for the development, fixing, washing, and drying of a film, whereas manual processing techniques require approximately 1 hour. The automatic processor maintains the correct temperature of these solutions and adjusts the processing time. Proper maintenance of the automatic processor reduces the chance of errors during film processing. Many dental offices that have automatic processors still maintain manual processing equipment as is standby if the automatic processor malfunction. Components of the automatic processor. So the processor housing covers all of the component parts. The film feed slot is for the unwrapped films to be inserted into the automatic processor. The ruler film transporter is a system of rulers that rapidly moves the film through the compartments. The developer and fixer compartments holds the solution. The film is transported directly from the developer into the fixer without a rinsing step. The water compartment holds circulating water. The drying chamber holds heated air and dries the wet film. So in figure 5, in figure A, it is an automatic film processor, while in figure B, an automatic film processor equipped with a daylight film loader. So advantages of automatic film processing. So less processing time is required, time and temperature are automatically controlled, less equipment is used, less space is required. In processing errors, so processing errors may occur for a variety of reasons, including time and temperature errors, chemical contamination errors, film handling errors, lighting errors. The dental assistant must be able to recognize the appearance of common processing errors and know what to do to prevent such problems from occurring again. Examples of common processing errors. The following photographs illustrate common examples of technical errors that can occur during film processing. Such errors result in radiographs that are not diagnostic, thus requiring retakes and additional exposure to the patient. Here in figure 6 shows the overdevelopment of teeth. So, figures developer splash, and figure 8 it is a scratch film. Figure 13 and 23, the water spats. Figure 9, solution 2, slow. In figure 10, ruler marks. Figure 11 shows the fingerprints. In figure 12, overlap films. Figure 13, underdeveloped. Figure 14, reticulation. Figure 15, fixer spots. In figure 16, developer cut off. In figure 17, shows the number of errors. In figure 18, fixer cut off. In figure 19, air bubbles. As you can see there in the arrow, you can see those air bubbles. Next is the black fingerprint in figure 20. Figure 21 is static electricity. In exposure to light in figure 22. In figure 23, fog film. Thank you.